Hey students, Mr. Murphy back again. We are talking about lesson 5, negative exponents and the laws of exponents. So we learned what an exponent is, we learned how to multiply exponents of the same base, we learned how to divide exponents of the same base, we've learned how to take exponents and raise them to a power, and we've learned how to multiply numbers that are raised to a power, and all of that fun stuff. We learned what the exponent of 1 is, and we learned the exponent of 0. So now we're going to talk about negative exponents. So the definition, any non-zero number x for any positive integer n, then x to the negative n is 1 over x to the n. So that's it. That's the whole lesson. So this definition of negative exponent says that x to the negative 1 is just the reciprocal at 1 over x to the first power of x. So x to the negative 1, right, would be 1 over x to the first power. X to the first power is 1, is just x, sorry. So the reciprocal of x is 1 over x, right? Think about that for just a second. Did you think about it? I was paused while you were thinking about it. But if I have x to the first power, so I have x to the first power, that's going to equal x. The reciprocal of x to the first power is supposed to be x to the negative first power. And then that would be 1 over x to the first power. So the reciprocal of 1, if I flip 1 upside down, I still get 1. So this should also equal 1, right? And x to the first power we know is 1, so this is 1 over 1, which equals 1. So 1 is that special number that works no matter what. I went off the side of the page, right? X to the negative 1 is the inverse. That means 1 flipped upside down, it's still 1. So 1 over x to the first power should be 1 over 1, which still equals 1. So it works with this, so we're hoping it's true. So as a consequence of this definition for non-negative x and all integers b, we get x to the negative b power. So x to whatever power equals 1 over x to that power. So we're just going to verify the general statement by putting x equals 3, and then we're going to try b equals negative 5. So b to the negative, x to the negative b, and b is negative 5. That means we got x to the negative 5 equals 1 over x to the negative 5, right? But x is 3, so this is 3 to the negative 5 equals 1 over 3 to the negative 5. Okay? A lot of negatives, so we're getting really goofy. What's 3? What's negative 5? That's just a positive 5. So this here becomes 3 to the 5th. And that should equal 1 over 3 to the negative 5, right? Well, if our rule is a negative number is the reciprocal, then I've got to just flip this over. I could say it's 1 over 3 to the 5th, right? And what does that equal? Oh my God, that's so cool. I guess the easiest way to point to this is say 1 divided by the fraction 1 over 3 to the 5th power. When we're dividing by fractions, we multiply it by the inverse, so it'd be 1 times 3 to the 5th power, which is just 3 to the 5th power. So 3 to the 5th power equals 3 to the 5th power. That's the end of the first part of this lesson.